Hi there and welcome back to the Good Tutor Premier Prep SAT course. And in this video, we're going to finish up our look at the problem solving and data analysis subsection of the SAT math section. And specifically, we're going to take a look at understanding scatter plots because they're going to be pretty important on questions relating to problem solving and data analysis. And you may see them on both sections, math sections of the SAT, calculator and no calculator. All right, so scatter plots are graphs that use a series of points, or just really a bunch of points, and can be formed around what is called a line of best fit. And a line of best fit is, it doesn't hit every point, right, like the typical line, but it just kind of makes it's also called sometimes a trend line, meaning it fits the data pretty well. Like it is formed around the data. So it doesn't go through every point, but it fits the data well. And I'll show you what I mean by that in a second. So the equation of this line is what allows us to display the relationship between the variables, x and y. So the kind of scatter plot that we see tells us a lot about the actual equation of the line of best fit of that graph. So in this case, like here is this scatter plot I have here. If we were to draw a line of best fit, it would probably look something like this, right? So this doesn't go through all those points, but it's a great point that represents these points pretty well. Of course, it's increasing, right? It's a linear equation there, right? Because it's just a line, it's not a parabola or anything like that. So it's linear, but it's also positive because we see it's a line that has a slope that's going upwards, right? So this would be linear and positive, the equation of this line. So it would be in the form of y equals mx plus b, right? The slope-intercept form of a line. So let's view now all of the different options we have basically when we look at scatter plots and what that means for the equations of the lines of best fit. All right, so to start with this list, we see if we have an upward sloping straight line like the one we saw in the last one, then the relationship between the variables is linear and positive. So that's going to look something like this. The opposite of that is a downward sloping straight line. And that means that the relationship between the variables and, of course, the equation, and we'll put that over here because this is really the equation, right, is linear and negative. So it's linear but with a negative slope. So that y equals mx plus b will have a negative m value, right, a negative slope. The next one says an upward opening parabola. So that will look like that. And that's going to be a quadratic equation with a positive coefficient in front of the squared term. So, right, the parent form of a quadratic is ax squared plus bx plus c. So it's saying that it's going to be a quadratic like that, but with an a value that's positive. All right. A downward opening parabola like that is going to be still a quadratic, right? Because quadratics are represented by parabolas, but it's going to have a negative coefficient. So that a value right here is going to be negative instead in that case. All right, an upward sloping curve with an increasing slope. And that's going to look like this. If that's the graph, then the line's going to go like that, and it's going to shoot upward. And that means that it is exponential and positive. And this is known as exponential growth. However, if we have a downward sloping curve with a flattening slope like that, that's going to be exponential and negative, that line. And that's going to mean that's what's called exponential decay. And typically the examples you'll see for exponential positive growth or exponential growth is going to be like the growth of a bacteria is the most common example used in the SAT. And then for this one, the negative or exponential decay, radioactive decay and half-lives are going to be the most common example of that. So you'll see that a lot in your practice. All right, so if we were to just sort of make an example, a lot of questions that ask about these may give you a scatter plot. So they'll give you a graph like this, and then they'll give you a bunch of points like this. And you have to figure out, okay, what is the line of best fit? What does it look like? And then they may ask you, okay, so what would be sort of the parent form of the equation for the line of best fit? So if you looked at this, you'd go, okay, well, it kind of looks like that, right? It looks like a parabola to me. So it's a parabola. And then we have to ask ourselves, okay, what direction does it open up? And it's opening upwards, right? So upwards. And if we went back and we referenced that chart, if you want to pause the video and do that, you would see that then we need a parabola is going to be a quadratic. So it's going to be ax squared plus bx plus c. And because it's opening upward, that a value is going to stay positive. It's not going to be negative or anything, okay? So if we wanted the parent form of this, of the equation for the line of best fit, it would look something like that. make sure you definitely study that chart that we have and just practice drawing each of those so you have an idea, and maybe even put flashcards so that you can remember which description matches each equation and then the graph that goes with it. All right, that is it for problem solving and data analysis. Up next, we'll get into a section known as miscellaneous topics in math.